Hello all. In today's session, we'll be discussing what is IPv4 addressing, what is classful addressing, as well as we'll write Python code for checking whether the address entered by the user is valid or not, whether it is a valid IPv4 address or not. Right? So, user will be entering an address. User will be giving an IP version 4 address as an input, and our Python code verify whether the given address is valid or not, right? As well as from the entered address, if it is valid IP4 address, then our Python code will identify to which class that particular address belongs, whether it belongs to class A, B, or C, right? And finally, we'll separate out the network address and the host address or the node address from the given IP4 address, IP version 4 address. Right. So let's discuss initially what is IP version 4 address. Right. So basically, whenever you are talking about IP addresses, right, or those are also referred as internet addresses. So these are not the actual addresses given to the devices, but these IP addresses or internet addresses are the identifier used in the IP layer of the TCP/IP protocol to identify the connection of each device to the internet. Right. So these are nothing but the addresses given to the internet connection. Okay. So these are not the actual addresses given to device, but these are the addresses given to the internet connections established by those devices, right? So as you know that in TCP/IP protocol suite there are 5 layers starting from the bottom layer, that is physical layer, data link layer, network layer, transport layer, and application layer. So at the network layer, these IP addresses are utilized. So there is IP protocol available at the network layer of the TCP/IP protocol suite. Correct. So these IP addresses are of 32 bits. So as these are of 32 bits, so there will be total 2 raised to power 32 addresses. So if you compute this value, so there are more than 4 billion of addresses available, right? So which can be assigned to separate internet connections established by the devices, right? So as I said that IP address is the address of the connection, not actually assigned to the device, but these addresses are assigned to separate connections. As you know that IP version 4 addresses are unique, right? So why you are calling it as those addresses as unique? Because each connection will be having a separate IP address. So there will be only one address given to a single connection, right? So IP version 4 addresses are unique in the sense that each address defines one and only one connection to the internet. So if that connection has been terminated, and if you are again connecting to the internet through same device, it may possible that in the subsequent connection you will be getting some separate IP address, not the same IP address which has been given in the previous internet connection, right? So your device will be located by tracking the IP address of that particular connection established to the internet. So there is another scenario if a device has two connections to the internet. Just for example, if you have a laptop, okay, so if you are connecting your laptop or PC through the LAN Ethernet cable, right? So that is the one internet connection. Another internet connection you are connecting through your mobile Wi-Fi hotspot, right? So you are connected to your same device. There are two active internet connection in the same device, one with the Ethernet LAN cable and another with the mobile Wi-Fi hotspot. So these two connections will be having two separate IP addresses, right? So both these internet connections will not be having same IP address. Okay, it may happen that both these connections will be having two separate internet addresses. Right. Now, the address space provided by the IP version 4. Right. So this IP version 4 uh, is of 32 bit. Right. So address is of 32 bits. So the address space will be 2 raised to power 32. Right. So address space is nothing but the total number of addresses used in that particular protocol, right, or provided by the addressing scheme. Correct. So as IP version 4 is of 32 bit, so there will be total 2 raised to power 32 addresses, so which will be more than 4 billion of addresses, right. So these many addresses are available in IP version 4. So there are three common notations which can be used to show an IP version 4 address. First one is the binary notation, it has base 2. Second one is the dotted decimal notation, it has base 256, and uh, third one is the hexadecimal notation, so it has base 16. Let's see how these notations are used to indicate IP version 4 address. So in this diagram, basically these three different notations are used. First one is the binary notation. It has base 2, right? Why base 2? Because it is using binary digits, right? So it will be having only two values, 0 or 1, right? So therefore it has base 2. In case of dotted decimal notation, it has base 256. So here, as you can see that IP version 4 address is of 32 bits, right? Correct. And it is divided into the combination of 8 bits. These 32 bits are divided into combination of 4 8 bits. So this first octet is of 8 bits, second octet is of again 8 bits, right? This will be of 8 bits, again this will be of 8 bits. So same has been indicated. This is of 8 bit, 8 bit, 8 bit, and 8 bit. So total 32 bits are there, it multiplied by 4. So in case of dotted decimal notation, each octet is of 8 bits, so 2 raised to power 8 is nothing but 256, right? So this value will can vary from 0 to 255. So 0 to 255, total 256 values can be there, right? So therefore its base has been indicated as 256. So this value can be from 0 to 56. Again this value can be from 0 to 256, sorry, 0 to 255. This value can be from 0 to 255. This can be from 0 to 255. Again this can be 0 to 255. It can be from any of 0 to 255 values, correct. And this third notation is called as what? Hexadecimal notation. It has base 16, right. Let's see how this address is represented in binary or hexadecimal notation. In common practice, we are using dotted decimal notation for representing IP version 4 addresses, right. So let's take same example here, that is the IP address is given as what, 128.11.3.31 is there, right, or you can also call it 128.11.3.31, right. So we can represent this address in binary notation and hexadecimal notation. As you know that in case of binary notation, right, if I am using 8-bit combination, so the values of each bit starting from the least significant bit, so least significant bit will be having value 2 raised to power 0. Then there will be, I'll simply write it here, okay. So least significant bit will be having value 2 raised to power 0, right. Then next bit will be having value 2 raised to power 1. Then next bit will be having 2 raised to power 2, 2 raised to power 3, then 2 raised to power 4, 2 raised to power 5, 2 raised to power 6 and 2 raised to power 7. So these are the 8 bit, right? So least significant bit will be having actual value 1, then 2 raised to power 1 is nothing but 2, 2 raised to power 2 is 4, 2 raised to power 3 8, then 16, then 32, then 64, and last one will be 128. So this is how the values can be represented by using 8-bit combination, right? So if I want to represent 128 using this 8-bit combination, so I can keep first bit as 1, right? I can keep first bit as 1 because the value of this first bit is 128 and the remaining bits will be all zeros. Okay, so this bit will be 0, this will be 0, this will be 0, and so on, right? So again there will be 4 zeros. So this is nothing but 128, okay, in binary, correct? Then there is value 11. So for 11 what I will be doing, I will keeping this value, this bit value as 1. So 8 plus 2 plus 1 will be 11. 8 plus 2 will be 10, 10 plus 1 will be 11. So all other bit values will be 0. So this bit value will be 0, again next bit value will be 0, this bit value will be 0, again this bit value will be 0, this bit value will be 1, right? That is 8, then plus 2, then plus 1. Okay, that is 8 plus 2 plus 1 will be 11. So this is nothing but 11 in case of binary, right? So 11 represented in binary form. The next value is 3. So 2 plus 1 is 3. That means I will be keeping only last 2 bits as 1 and remaining all bits will be 0. So 0 0 0 0, right? 0 0, and simply last 2 bits will be 1 1. So this is nothing but the value 3. Okay, so 3 is represented in binary form. Next I have to represent 31. So 31 will be 16, 16 plus 8 will be 24, right? 24 plus 4 will be 28, 28 plus 2 will be 30, 30 plus 1 will be 31. That means I have to keep all last 5 bits as 1 and first 3 bits will be 0. So first 3 bits will be 0 and remaining 5 bits will be 1. So 16 plus 8 plus 4 plus 2 plus 1 will be 31. Okay, so this is nothing but 31 in binary. So this one is what called as binary notation used to represent an IP address, and this was what dotted decimal representation, right? So this was dotted decimal representation. So same has been indicated in this diagram, right? As you can see that 1 all zeros, 1 all zeros for 128, then 4 zeros, 1 0 1 1, 4 0 1 0 1 1 is nothing but 11, right? And then first 6 bits are 0, last 2 bits are 1, that is nothing but 3. And for 31, first 3 bits are 0, last 5 bits are 1, first 3 zeros, last 5 bits are 1. Now if I want to represent this in hexadecimal, so what I will do, I will simply because in case of hexadecimal 4-bit combinations are used, so 2 raised to power 4 is equals to 16, right? So in hexadecimal notation, the hexadecimal code will be of 4 bits, right? So you can represent 16 different values by using 4 bits, and those values will start from 0 to 9 will be there, right? First 10 values will be represented 0 to 9, and the remaining 6 values are represented as A to F. So A is nothing but 10 and F is nothing but 15, right? So total 0 to 15 values are represented in hexadecimal number system. So those 16 values are represented simply as 0 to F, right? So first 10 values will be 0 to 9 and last 6 values will be A to F. So to represent these binary values in hexadecimal, I will be simply divided into 4-bit combination, right? So as you can see, the last 4 bits are here 0. So this is nothing but value 0 in hexadecimal, right? If you represent these 4-bit value, because if I want to represent 4-bit value, so again I'll be using it as 2 raised to power 0, then 2 raised to power 1, then 2 raised to power 2 and 2 raised to power 3. That means the last bit value will be 1, then this will be 2, this will be 2 raised to power 2 means 4, and this is 8. So if all bit values are 0, then it is representing simply 0. If first bit value is 1 and remaining 3 bit values are 0, then it is representing 8, right? So first bit value is 1 and last 3 bits values are 0, so it is representing 8. Again, here also I will be dividing into 4-bit combination to get the hexadecimal notation, right? So here, as you can see, the uh, value represented by these 4 bits is, so this is 8, right? 8 plus 2 plus 1, so it is 11, right? 8 plus 2 plus 1 is 11. So in case of hexadecimal notation, 11 is represented by B, right? A is for 10, capital A is for 10 or small a is for 10 and B is for 11, right? So 8 plus 2 plus 1 and again it is 0. So 0B will be there. And in this case, again, if I divide it into 4-bit combination, so this is nothing but value 3, that is 2 plus 1 3, and all zeros means again it is 0. Again, if I will divide it into what, 4-bit combination, correct? So this is F, because it is 15, 8 plus 4 plus 2 plus 1, that is 12 plus 3 15, right? So it is represented by F, and this is nothing but simply 1. So same has been indicated here, that is 80-0B-03-1F, 80-0B-03-1F. So this is how you can represent an IP address in dotted decimal notation or binary notation, or last one was the hexadecimal notation, correct? So hexadecimal notation has base 16, this binary notation has base 2, and dotted decimal notation has base 256, correct? So let's see how these addresses used hierarchy, right? So as you know that whenever you are talking about mobile number, so mobile numbers are starting with the country code followed by 10-digit mobile number, okay? So that is the hierarchy used in case of mobile number. If you are talking about landline number, so in case of landline number, we are using again country code, then you are using the city code, and followed by the actual landline number or phone number, right? So that is the hierarchy used in the phone numbers. When you are talking about the IP version 4 address, so it is divided into 2 parts. First one is the network address, and it is followed by the host address, which is also called as the uh, device address, actual device address, right? So these 2 parts are simply referred as prefix and suffix, as indicated in this diagram, right? So as you know that the IP version 4 address is of 32 bits, so it is divided into prefix and suffix. If you are considering prefix of n bits, so suffix will be of remaining bits, that is nothing but the 32 minus n bits, right? So this prefix indicates the actual network address, right? While suffix defines actual nodes or the host. These are also called as host addresses or node addresses, right? So single network comprises many hosts or nodes, right? As well as there can be many networks. So each network comprising again various or numerous number of devices, right? So in case of IP version 4 hierarchy, IP version 4 address is divided into prefix and suffix. If prefix is of n bits, so suffix will be of 32 minus n bits. So this hierarchy is used to define the classful addressing in case of IP version 4, right? So this uses the classful addressing. So there are total 5 classes, that is class A, B, C, D and E, right? So how these addresses are defined by using prefix and suffix. So in class A, this prefix will be of 8 bits. As we have seen in the previous slide, this 32-bit address is divided into combination of 8 bits, right? So in class A, this prefix will be of 8 bits. So what does it mean? So if I am taking 2 raised to power 8, so it will be 256. So there will be total 256 networks in case of class A address. How many networks? 256 network, because prefix is of 8 bits, right? So if I am considering all 8-bit combinations, correct? And remaining 24 bits are used for suffix. As you can see here, remaining 8 bits are used for suffix, right? Sorry, remaining 24 bits are used for suffix. So there will be total 2 raised to power 24 devices in these 256 networks, correct? So as you can see that most of the addresses from the available address space, how many addresses are there? So 2 raised to power 32 bit addresses are there, right? So more than 4 billion addresses are there. So out of those 4 billion addresses, 50% addresses, that is more than 2 billion addresses, are used in case of class A addressing, right? While 25% addresses are used by class B, and remaining addresses are distributed for C, D and E, right? In this diagram you can see that there are 5 classful addressing used in case of IP version 4: class A, class B, class C, class D and class E. Simply, in case of class A, prefix will be of 8 bits. In case of class B, prefix will be of 16 bits. So remaining 16 bits will be used for the host addresses or node addresses, right? So in case of class B, if you are talking about class B, so there will be 2 raised to power 16 devices in each network, right? So total 2 raised to power 16 devices will be there in each network in case of class B. While in case of class C, as suffix is of only 8 bit, so in case of class C, there will be only 2 raised to power 8, that means only 256 devices will be there in each network. While prefix is of 24 bits in case of class C. While class D is not divided into prefix and suffix, so it is used as the multicast addresses. Whatever addresses available in class D, those addresses will be used as multicast addresses for sending messages to multiple devices, right? While class E, again, it is not divided into prefix and suffix, but this class E is reserved for future use. So whenever you are using internet, the addresses, IP version 4 addresses, are assigned from these 3 classes, that is class A, B and C, right? So if you are sending addresses messages to multiple devices, in that case multicast addresses might be assigned. Now let's see how this table has been derived from these addresses: class A, class B, class C, right? So as you can observe, this particular these classes here. So if I'm talking about class A, right? So in class A, this prefix is of 8 bits, right? In class B, it is of 16 bits, right? In class C, it is of, as you can see, sorry, 24 bits, right? And in case of this class D and class E, it is not divided into any prefix address, right? But if you observe the first 8 bits, right, first 8 bits or first byte, okay, of these addresses. So in case of class A, first bit from the 8-bit combination is always 0, as you can see here. Okay, it is always 0. That means it is not actually creating 256 networks because first bit is always 0, right? While in case of class B, first 2 bits are 10, right? In class C, first 3 bits are 110, right? As you can observe here, it is 110, first 3 bits. In class B, from first 8 bits, right, these 4 bits are 110, right? As you can see, it is 110. And in class E, first 4 bits are 4 times 1, as you can see here, right? So if you take or extend these values, right, as you can see, in case of class A, these first 8 bits, as you can see, the first bit is 0, so remaining 7 bits can be varying from all zeros, right, to, as you can see, that the first bit in case of class A is what again? It is 0, right? And it goes up to again all 1, right? So that means in class A, the addresses starts from, because in case of IP version 4, you are using or dividing the 32-bit address into the combination of 8 bits, right? So by using the first 8-bit combinations, you can identify whether that address, IP address, belong to class A, class B, class C, class D, or class E, right? So as you can see, in case of class A, the first bit is always 0. So that means the addresses are starting from, if I'm taking first at 0, the remaining bits you can vary from all zeros to all ones, right? So the maximum value of the address is this one, right? And minimum will be this one, right? So in case of class A, okay, in case of class A, addresses are starting from 0 to, what is this value? So it is nothing but this first bit, 8 bit is 128, right? This is 64, 64 plus 32 plus 16, right, plus 8 plus 4 plus 2 plus 1, so it is 127, right? So if first 8 bits value is from 0 to 127, then that address belongs to class A, right? Similarly, you can identify it for class B, right? So I am talking about class B. So first 2 bits are always 10 in case of class B. So again, if I want to identify the ranges of address, from which address it will be starting, okay, so again, first 2 bits are 10 and remaining 6 bits can vary from all zeros to all ones, right? So remaining 6 bits will be varying from all zeros to all ones, right? So again, if I calculate this value, as first bit here is 1, so it is 128, remaining bits are 0. So address, class B addresses are starting from 128. Okay, 2. Again, this is 128 plus, this is 32 plus 16 plus 8 plus 4 plus 2 plus 1. So it is, I think, 191. Okay. So as you can see here in this table, those addresses has been indicated. Okay, 0 to 127, 128 to 191. Right. So that means in case of class A, this first octet will vary from 0 to 127. Remaining can be from 0 to 255, 0 to 55 to 0 to 255. But first value can be from 0 to 127 in class A. Right. Similarly, in class B, it can be from 128 to 191. Similarly, you can identify it for class C. As you can see here, first 3 bits will be always 110, right? Remaining 5 bits can be varying from all zeros to all 1, right? And first 3 bit here are 110, correct? So here, as you can see, this can be, if you calculate this value here, right? So 128, I'm talking about now class C. So it is 128 plus 64, so it is 1922. It is again 128 plus here 64 plus this 32 plus 16 plus 4 plus, sorry, what is that, 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1. So if you calculate this value, so it is 223, correct? So in similar manner, you can identify it for class D and class E, right? So the remaining 4 bits can vary from 002, 4 times 1. Here again it can vary from all zeros to 4 times 1. Okay, so these are the ranges of IP addresses from where these addresses are starting. So here the first 4 bit will be always 110, and here first 4 bits will be always 111, right? So here you can identify again, if you calculate this value, this is class D and this is class E. As you can see, in class C we have computed 192 to 223, so 192 223, right? So here if you calculate this value for class D, so it comes to 224 to 239, right? This is for class D. 128 plus 64 plus 32, right? So it comes around it comes to 224. If you add those values, then again it is 128, 64 plus 32 plus 8 plus 4 plus 2 plus 1, so it is 139, sorry, 239. Okay, so these are the values for first 8-bit combination for class D. So it falls in this range, so it is class D address. Similarly, if it is class E address, so it is ranging for 242, as all ones are there, so it is 255. Okay, so this is how these values from 0 to 255 are used to define these classes. So if values are from the address is starting from 0 to 127, so it is class A address. If it is 128 to 191, class B address, and so on. Okay, so this is how this classful addressing is defined here, correct? Fine. So now let's see the Python code, right, for identifying whether the given IP version 4 address is valid or not. Then if it is valid, to which class it belongs, and then we'll divide the prefix and suffix part to identify what is the network address and what is the host address. Okay, so as you can see in class A, okay, the values of first 8 bits, as you can see here, first 8 bits are used for network address, right, and last 24 bits are used for host or node addresses, right. But out of these 8 bits, first bit is always 0, so there can be only 0 to 127 values, so total 128 addresses can be there, right. So 128 networks are there, okay, in case of class A IP address. 128 networks are there, and in each network there are 2 raised to power 24 nodes, right. So 128 networks are there, and in each network there can be 2 raised to power 24 nodes. So let's see the Python code to check all these concepts. Okay, so here I have already specified code in this Python script with name validate identify class. Okay, validate IP address and identify the class of IP address. So from here the execution of code will be starting. So using this input function, this message will be displayed and an anaconda prompt. Okay, so I will directly initially execute this code. So it is stored in this folder basically, that is identify IPv4 class folder is there. It is in G drive, right. So initially I will switch to G drive, okay, and then I will switch to this directory where that code is saved. Okay, so here I will write cd, paste that path, and then I will run that Python script. The name of the script is validate identify class. Okay, so I just entered it, correct. So first statement it will be displaying is nothing but enter valid IP address, correct. So whatever value I will enter there, the input function will read that value and it will store in this variable, that is IP, right. So that message has been displayed. What is that? Enter valid IPv4 address. So here if I entered any address, so just for example 192.168.0.1, so once I will enter this will be assigned to this IP variable, okay, and then print through print function. Inside that print function I have passed what? Valid IP address function, and to this function I am passing this IP address which I will be entering here, that is 192.168.0.1. that is, instead of point you can call it as dot 192.168.0.1. okay, why dot? Because it is dotted decimal notation. Okay, so this valid IP address is the function defined in this program, so it is user defined function. So initially this input, print are these were the predefined function. Valid IP address is the user defined function, so its definition has been written here, that is valid IP address. Okay, here I am defining this function, correct. To this I am passing IP address which will be what you can say which is nothing but the string, and it will be simply returning string. Okay, this function will return a string. In this code I am using the library IP address. From this library I will be using IP underscore address and IPv4 address, right. So as you can see inside the definition of valid IP address, to which I have passed the IP. So here this IP address will be passed 192.168.0.1 and it will read as string. Okay, now this function has try catch block or try except block, so it will be returning IPv4 Okay, so it will be returning the string when if the type of that IP address. Okay, so this is the predefined one IP address to which this now 192.168.0.1 has been passed is IPv4 address. So if it is IPv4 address, so it will be returning string IPv4. Okay, else it is returning string invalid. So it is not valid IPv4 address because we are simply checking IPv4 address here, right? And if it is there any value error, so this except block will be executed and it will be again returning invalid. Okay, so depending on what you have entered through the input function, okay, so it will be returning IPv4 or it will be returning invalid, right? So if type of that IP address is IPv4 address, IP version 4 address, so IPv4 will be returned, right? So in this case I have entered IPv4 address, so IPv4 will be returned and this will be the output of this function. Okay, so this valid IP address will be returning value IPv4. So as you can see here, if I press enter, right, so this has been printed. What has been printed? IPv4 has been printed here, correct? So just for example, if I'm again executing this code and if I am entering any invalid address, just for example, as you can see that no address will start from this range, right? So if I am just entering this value, okay, and I press enter, so as you can see here, what has been written? Invalid, correct? Because it is not a valid IP version 4 address, correct? Now let's see further execution of the code. So if this valid IP has written IPv4, then this if block will be executed. Otherwise, this else part will be executed. What is else part? Enter value is not valid IP address. Enter valid address. Okay, as you can see, when we entered invalid address, so this statement of else part has been printed. Enter value is not valid IP address. Enter valid IP address. Okay, so if it is a valid IP version 4 address, then what we have done from that IP address, so in previous case it was 192.168.0.1, so this has been splitted, okay, by using dot. So it will be splitted into 4 parts. So first part will comprising 192, second will be comprising 168, third will be 0 and fourth will be 1, separated by dot. Okay, so one by one it will be read from this IP value and will be assigned in IP. Okay, so this IP will be comprising now these 4 parts, that is 192, 168, 0 and 1, depending on what IP address you have taken, valid IP version 4 address you have taken here. Okay, so after that this value has been passed to find the class of that IP address. So again this find class is the user defined function. So let's see how this find class has been defined here. So whatever the ranges that we have defined initially, right, for class A, B, C, D and E, right? So here you can see here that this find class you have passed the actual IP comprising, this is not actual IP but this IP is comprising 4 values, okay, that is 190, if I am considering this IP address, so it is comprising 192, 168, 0 and 1, 4 different values, right? So from those 4 different values I am just checking the first value. As we have seen in the slide, we will be interested in this first byte, okay? So for class A it will be in this range, that is in 0 to 127. So that has been checked here. So if this first value is from 0 to 127, then it will be of class A type. So if the first value, that is IP of 0, IP of 0 is 192, right? IP of 0 is 192, IP of 1 is 168, IP of 2 is 0, and IP of 3 will be 1. But we are interested in only first 8 bits there, that is IP of 0. So if it is from 0 to 127, so it is class A. If it is from 128 to 191, so it is class B. But in our case, it is 192. So this particular block will be true, or this condition is true, right? Because our value falls in this range, that is, it is greater than or equal to 192, as it is 192, and it is less than 223. So therefore, it will return this particular C string. Okay, and if value is between 224 to 239, so it will return D. So that means your IP address will belong to class D, else it will return E. So remaining, if there is any remaining value that is from 240 to 255, then it will be class E, right? So in our case, it is 192. So this particular block will be executed, and it will return C, right? So as you can see there in this particular find class of IP, so network class now comprise value C, right? So that value is printed here by using print statement given IP address belong to class, network class hold value C. So therefore, in this statement you can see given IP address belong to class, C has been printed, right? Now next we have to separate that address into the network address and host address. For that purpose, again, from this IP address, we have taken all those or passed those as string there, and by executing separate function where this IP and network class, so network class is C, because depending on network class, what is the size of prefix will be decided, whether it is of 8-bit, 16-bit, 24-bit, right? If it is 8-bit, so the network address will be of 8-bit, and host address or node address will be 24 bits, right? If it is this network class is B, right? So 16 bits are there, so your network address will be of 16-bit, host address will be of 16-bit. And similarly in class C, 24 address will be used for network address, and host address is of 8-bit. So again, this separate function is defined here, right? So IP has been passed as string. So this will become 192, 168, 0 and 1. Okay, so let's see the definition of this separate function. So here you can see the definition of separate function. Okay, so IP and class name has been passed here. So again, condition has been checked depending on what is the class name. If it is class A, so you will say that this network address will be simply 192. Okay, sorry, it will be, if it is class A, so the network address will be from 0 to 127. Okay, depending on what IP address you have entered. As in our case, you can see that because the first 8 bits in class A will be used as network address, and last 24 bits are used as the host address, correct? So similarly, in case of class B, first 16-bit address, that is nothing but IP of 0 and IP of 1 will be used as network address, while IP of, you can say, 2 and 3 will be used as the network address. This 1 to 4 will comprise only 1, 2 and 3 value, while IP of 0 is taken as network address. Here this 0 to 2 means 0 and 1. IP of 0 and IP of 1 will be used as network address, while IP of 2 and IP of 3 will be used as host address. And we are joining these by using again dot, right? We are separating those addresses. So in our case, As our class name is C, this block will be executed. So network address will be the first three values there. Okay, that is IP0, IP1 and IP2. IP of 0, IP of 1 and IP of 2. So IP of 0 comprising 192, IP of 1 168, IP of 2 comprising 0. So this is nothing but our network address. While what is the host address? So simply the remaining value, that is IP of 3. Okay, because this IP of 3 is 1 here, right? Because in case of class C address, first 24 bits are used as network address and last 8 bits are used as host address, right? Otherwise this else part will be executed. So in this class, that is the remaining class are D and E. So in this class, IP address is not divided into network and host address as we have seen in this PPT, right? So in class D and E, those are not divided as network address and host addresses, right? So this is how our code has been written here to verify the IP address, right? We are validating the IP address, right? We are checking to which class that IP address belongs, correct? So by using this code, we are checking to which class that find class function we have defined for that, and finally we are separating that IP address into network address and the host address, right? By using this function, correct? To verify to which class it belongs. Sorry, to divide it into network address and host address depending on uh, to which class that IP address belongs. And this is our main code from where the execution will start, right? So this is our main code. Okay, and for this code we have used this IP address library. From this we are using IP address and IPv4 address. Okay, so we have seen one case here of class C. So for class A address, we need to enter the IP address which will be starting from 0 to 126. So just for example, if I am entering 126.34.45.2, okay. So in this case, it will indicate it is a valid IP address, as well as it will indicate it belongs to class A, right? In this case, the network address will be 126 only, and the host address will be this one. Okay, so this output should be displayed by the program. Okay, so as you can see, the class has been indicated as IPv4. It is valid one. Given IP address belongs to class A. The network address is 126 and host address is this one. Okay, so this is how you can identify classes through Python code. You can also verify whether it is valid IP version 4 address or not. Even you can separate that, if it is valid IP version 4 address, then you can separate it into network address and the host address. So thank you.